Welcome to Pomodoro Joe for Wednesday, March 1st, 2023. Today we're doing LeetCode problem 912, sort an array. It's a medium problem. Given an array of integers nums, sort the array in ascending order and return it. Okay. You must solve the problem without using any built-in functions in O n log n time and with the smallest space complexity possible. Ah, man. Fine. All right, let's see what we got. We'll put 25 minutes on the Pomodoro timer and get started. So we have to do this in O n log n time. Well, let's see. I don't really remember my sorting algorithms that well. So let's do merge sort first. And then if merge sort doesn't work, we'll try the quick sort. So the way merge sort works is given an input array, you split it in half. Then you split it in half again, and you split it in half again. You basically keep splitting it in half until you get down to just one element in the array that's already sorted then. Then when you return, you basically merge your return values together, your left and right merged together by essentially looking for the smaller element in the left or the right, putting that in your result, and you keep sort of popping them off until you end up with your result, and then you can return that result. Yeah, I'm not explaining this well at all, so let's just write it. So we'll do merge sort, and we'll call this A for our array. All right, so the base case in the merge sort is just if this is one element long, we just return it. So we'll say if it's less than 2 in case we have empty arrays. Okay, the other part is now we have to split this array into 2 pieces, so we have to find our midpoint. Okay, so our midpoint will be the length of our array divided by 2. So the left will be our array up to the midpoint, and the right will be our array from the midpoint on. Okay, now we need to actually do the recurse. So we actually will do a merge sort on the left and a merge sort on the right. And let's see, let's reset these here. We could modify them in place, but I think that's going to be more complicated, so let's just set them at this point. And now that we have to do the merge. So for this one, while we still have elements in our left and right, we're going to compare essentially the first element or the lowest element in left and right, and we'll put those in our result. So let's see, we'll need a result here at some point. Let's create our result. Okay, so while we have a left and right, so if the first element in our left is less than the first element in our right, we'll put the left element into our result, and then we'll keep going. So we'll actually pop the element out of left, so we're actually modifying our left to remove that element, and our result, we will add this element. Otherwise, we'll do the same, but on the right side. And finally, our result, now that we've gone through left and right, we might still have some elements in left or in right. So we have to say our result will be equal to our result plus whatever's left in our left plus whatever's left in our right. One of these two will be an empty array, but that's okay. When we append the empty array, it's not going to take up any space in our result. And finally, we will return our result. Okay, and then for our sort array, we actually need to call this, so we will return our merge sort on our nums. All right, let's take a quick look through our merge sort here. We get an input A, that's some array. If it only has one element or less, we'll just return it. Otherwise, we'll find this midpoint. We're going to split our array into 2 pieces, the left half and the right half. The left half goes up to the midpoint, and the right half goes from the midpoint to the end. Okay, then we will call merge sort on the left and merge sort on the right. So we're going to be basically sorting the left and then sorting the right. All right, then when we get the left and right back, we'll go through and just pop out the smallest values one at a time, appending them to their result. And then finally, we'll just merge them all together into one final result. All right, let's run that and see how we do. And we pass. Let's see if we can pass all of the runtime. Okay, so we do pass. We only beat 24% for runtime and 17% for memory, so not great. Let's go through this and try quick sort. So this is our merge sort. Let's do a quick sort here. See if we can beat the merge sort algorithm. So quick sort is similar but different. So with quick sort, we'll still be finding some midpoint, but in quick sort, it's not really a midpoint, it's a pivot point, and it could be any element in our array. So we just choose some element in the array. That becomes our pivot point. Then we go through all of the elements of the array and find all the ones that are lower than our pivot and put them in one array. And we find all the ones higher than our pivot point and we put them in another array. Then we call quick sort on each of those. Very similar to how we break down the merge sort. Instead of using the midpoint though, we're using a pivot point, which could be anything. All right, so very similar here. If the length of A is less than 2, we'll just return A. Then we'll choose our pivot. And that's just going to be just some random element. So that'll be some random choice in our input. So now that we've chosen our pivot point, we need to go through all of the elements in our array, find the ones that are lower, find the ones that are higher, and find the ones that are the same, in fact. So let's see, we'll have a lower. That's going to be an empty array. We'll have same. And we'll have higher. Okay, and then for n in our array, if n is greater than our pivot, we'll put it in the higher. If n is lower than our pivot, we'll put it in the lower. And if n is the same, we'll put it in same. Okay, now that we have all of our elements, we're going to recurse on these and we'll have some result, and that will be equal to, well, we'll put the lower ones at the lower end, and so we'll quick sort those. And then we'll put the same, and then we'll quick sort the highers. And we will return our result. So in fact, I don't even need this result. I could just return. Let's just do that. Okay, let's just make sure we got this right. So if we have only one element in our array, we just return it. Otherwise, we'll choose some random pivot point. We'll have a lower, same, and higher. For every element that's higher than our pivot, we'll put it in the higher. For every element that's lower than our pivot, we'll put it in the lower. For every element that's the same, we just put it in the same. Then we'll sort the lower, append it to the same, and append that to the sorted higher. All right, so instead of doing our merge sort, we'll do a quick sort here. How do we do? Still pass. And how do we fare with the entire test suite? Not too bad. Now we're beating 81% for runtime and 21% for memory. So that's not bad at all. Let's see, we go from 24% runtime and 17% memory on merge sort up to an 81% for runtime and 21% for memory on a quick sort. Now there are definitely other sorting algorithms you can try, but these are the two that I can remember. The people who are getting 100% on this one are just calling nums sort, which is explicitly against the rules on this particular problem. So I wouldn't worry too much about getting a high runtime on this. If you only beat 81%, that's probably pretty good. It's going to be hard to beat the people who use the internal sort algorithm because that will be optimized. All right, folks. Now you know how to do a merge sort, now you know how to do a quick sort, and now you can go out and try this one on your own. Again, this is LeetCode 912, sort an array. Check it out, it's fun. Hope you enjoyed this, hope you had fun, hope you learned something, hope you can go out and write some better sorts.